What's up, YouTube? In this video, we're going to be looking at a very common object-oriented programming tenet called prefer composition over inheritance. And this is going to be quite different from probably other videos you've seen on YouTube and elsewhere maybe, where I'm going to be presenting a few things, a real-world scenario where this was employed as a way to kind of refactor, if you will. And I'm also going to take you through the paces of the design, the questions, and the reasoning behind why certain things are the way they are in this particular case. So it's going to be, I'm hoping, much more useful than just some toy example applications with just the kind of regurgitation of what's there in the Conf book. This phrase, prefer composition over inheritance, was first introduced in the Conf book. And they go through quite a bit of an explanation for why one should go down that route. Namely, it breaks encapsulation, or some people think or agree that that's what the case is. And others feel that it's not breaking encapsulation. There are a few other issues. I will discuss just one of them. And another issue that I find, and the reason that I actually gravitate towards composition over inheritance, is not in the Conf book. And I think that's, in my books, that's a lot more important than encapsulation on those kind of nerdy academic kinds of conversations. I'm more interested in sort of the real world. What is it? How is it impacting me in the real world? Whether it breaks encapsulation or not, I really don't care. So there'll be chapter markers. If you're wanting to skip ahead, please look at the chapter markers, because I will be discussing various things that are not pertinent to this topic itself, but my reasoning and the sort of thought process involved in getting to this solution. The source code for this video will also be available on my GitHub. You'll also see that, the link to that in the description below. All right. So if you've not watched one or two of my other videos, I talk about inheritance, and I'm not a big fan of inheritance. I use inheritance mainly for polymorphism, for the sake of polymorphism. There are two kinds of inheritance, again, from the Conf book. They talk about these two kinds of inheritance. One, inheritance is for the sake of extension, which is you inherit some base functionality from a base class or ancestor classes, and you want to extend or add more functionality on top of that, right? So inheritance for the sake of extension. I don't use that. That's not one of those features I sort of espouse to use or kind of gravitate towards. In fact, I stay away from that. The second reason for inheritance, or type of inheritance, is for the sake of polymorphism, because polymorphism depends on it. My opinion is that inheritance exists in object-oriented programming for the sake of polymorphism. It's not like you need it. It's very rare that you actually need something you can't do without inheritance. There's many scenarios where even if you implemented it using inheritance, there are other ways to do it. So knowing that, I already have a sort of a hesitation for using inheritance for the sake of extension. Keep that in mind, because that'll sort of feed into this example. All right. The example is a config provider, or a configuration provider, that we use in the applications I build. There are a few videos, at least a couple of videos on my channel on configuration provider. You can take a look at those. I'm also not a big fan of assemblies or packages, core packages, utilities packages, stuff like that. I don't like to share code across my projects or within the project. And there are many reasons for that. I won't go into all the details. That's not to say I don't do that. That's not my go-to. It takes me a long time into a project to resort to then refactoring some classes into a library that other projects in that solution can use, or across solutions. So the example that I have is an entire application that's comprised of multiple solutions that has multiple projects. So multiple solutions because each solution is a deployment. And so that sort of forces our hand to have this as a separate solution, because we deploy that solution separately from this solution. But the solutions themselves are comprised of multiple projects. And over a period of time, I'm talking about 7-8 months, 6 months and beyond, there comes a time where you've been copy pasting code from across your projects, which I'm okay with, by the way. I'm not averse to that. I got this rule of thirds that I say, which is if it happens 3 times, then think about it. As in you copy paste knowingly. So everyone has to be aware that that's been done and keep account. And if it happens for the 3rd time, that's when you want to sort of rethink your strategy, and maybe sometimes the 4th time. And then the strategy may not be like roll it up into some core or whatever the strategy ends up being, because then you have a much better understanding of all the different scenarios in which you've copy pasted, and are they all the same? Are there slight differences or variations in all of these things? Rather than jumping the gun and immediately starting with a core package or a reusable thing. I'm not a big fan of reuse. So I don't go down that route just automatically. So here we are in this project. I think there's 5 or 6 solutions. And there are some commonalities with regards to the Azure services we use. So we use Message Broker, we use storage, blob storage, we use Cosmos DB. Let's just stick to these 3. But not all projects require all 3. Some projects require 1, some projects require 2, and the 2 may be like a different set of 2, right? And so we obviously just copied the code over, and then it came to a point where we said, okay, now we have a good understanding of exactly how these different solutions are going to pan out and what their use kind of requirements are. Let's roll up these config providers into a library and then take it from there. The problem I have with libraries is the same problem I have in some sense, in an obtuse kind of layman's term sense, with inheritance as well. And I'll explain what that is. So with the library, you think you're doing something beneficial, reusable, because you put everything in a library. And then there's this one project that needs to use one class from this library, but this library has 200 classes in it. I'm just exaggerating here, but I guess you get the basic idea. Is that this library has access to things it's probably not supposed to have access to. And then the moment that happens, it becomes difficult to understand what part of, or what classes from this library is this project using and what classes should it be using, right? Because it's all there in the library. And then it becomes very difficult to break up these libraries into packages that are self-contained to the point where the classes in that package or library is only available, or the projects that are consuming it can only use, and they need all those classes. It's not like there's an overload of classes in the packages and these sub-projects that need 1, 2, or 3 of those classes, which is, as you can imagine, that's what happens. Unless the library itself has just one class in it, right? That's the ideal situation. Or a functionality. I don't mean by a class, I mean like a functionality. Like, for example, Newtonsoft. It's to do with JSON serialization, deserialization, and that's that. And that's perfectly fine, right? Because that's all it does. Maybe there's 10 classes in there, but that's all that's all the features you have there. So keep in mind the hesitation I have towards reuse, and especially when it comes to putting things into a package, rolling up into a package. As soon as you discover one more use and you start to, in fact, I know a lot of people who will start making libraries before they even write any code, because they sort of just imagine that I'm going to need this in a library and it'll be cool to reuse this and it'll be cool to reuse that. I don't reuse. That's not my go-to way of programming. So, okay. So this config provider, as I said, some projects require blob storage and Cosmos DB. Some require Cosmos DB and Message Broker. Some require Message Broker and blob storage. Some require only one. So it is a mix and match of these 3 different features, either 1 or 2 or 3, some combination of all of these. So the default way to implement that would be, so okay, let's take all of the functionality, put it into this base configuration provider base class, and then it's available to all descendants, or you don't have to even need a descendant. You just use that class directly in all your projects and you're done, right? And then each project can decide whether it wants to use that feature or not. So I have a problem with that right away, because now you are hoping that the devs on the specific teams know not to use that functionality, even though it's available to them in the class, right? It's available, you can see it. It's a public method, you can see it. If we say let's not make it public, let's make it kind of an ancestor, so the ancestors can decide which functionality they want to make public. Cool, we can do that. So then my complaint would be that it's not that it's public, but it's available, and nothing stops somebody from implementing that and making that method public in the descendant. Essentially, the problem I have is being given access to more than you need. And this goes to method design also. If you watch my programming with intent, the very first video in that playlist, I talk about method design, and one of the features I talk about, one of the tenets I talk about there is methods should be given exactly what they need, nothing more and nothing less. Nothing more and nothing less. And that same thing applies to ancestors. So if you're doing inheritance, make sure that the base class doesn't have any method. Forget implementation, even if it's just abstract base class. There is no method available on that base class that is not required by a descendant anytime, today and in the future. And that becomes quite a hard choice. And so that's one of the reasons I stay away from inheritance as well, besides the fact that I don't think inheritance for the sake of extension is something you want to kind of strive for. And here we are sort of using inheritance for the sake of extension, because we want to extend potentially and make some methods public and make that functionality available from the base class. The base class has all the implementation. The descendants can choose to make some 1, 2, or 3 methods public, depending on which project you're in. And on the face of it, that's cool. But that's inheritance. And we're talking about, or today's video is talking about, prefer composition over inheritance. Yes, I hope you understand the scenario I'm trying to build here and the potential problem with that. And if you look at my screen here, I have this little slide here that I've defined where there's a config provider base class, and you potentially have 2 descendants. One has message broker settings and Cosmos DB settings. The other one has blob storage settings. And then there's a descendant of that may need blob storage settings. And now, because you're going down this hierarchy, you got blob storage settings here, you got blob storage settings there, and you kind of get in this inheritance mess. You're not quite sure which way to go. Then there's various permutations to that mess as well. Of course, you could also say that just to roll it all up in the base class, and then the descendants can be for every project. It's less 1 level down or 2-layered kind of hierarchy, the base class, and all descendants are on this level here. And each project can decide to expose a protected method here, make it public in the descendants. Right? So you can alleviate that. So there's various combinations when you use inheritance that you can do and play around with. But at the end of the day, you're ending up with one of 2 problems, which is you are exposing functionality to descendants you don't want them to use. It's up to them to or not to use, right? From a design point of view. Or you're ending up in this situation where the hierarchy is so, it becomes a hodgepodge. Like you've gone down one hierarchy and this functionality here that you didn't need here. Now suddenly at the end somewhere you need this functionality from here, and it's a different branch, and it just becomes a mess, right? So I hope you understand my kind of basic heartburn with inheritance and with packages and so on, right? And the fact that this problem is trying to alleviate the main problem, which is when you have inheritance for the sake of extension, there's functionality available in the base class that is potentially not required in a descendant. So it's up to the descendant to kind of not use it. And from a maintenance point of view, tomorrow somebody can just add on that, oh, I got blob storage. Yeah, I can just use blob storage. And you're not supposed to be using blob storage in this project. Okay. So what's the solution? The solution is composition. And for those of you who don't know what composition is essentially a class that is comprised of multiple other classes, or the functionality or certain functionality is implemented by other classes. And we'll see examples of that. All right. So I'm going to show you now the code. All right. So just to highlight some of the basics, this is the config file where we have Cosmos DB settings. That's the config file, storage account settings, and message broker settings. Just to give you a sense of what's involved in this standard settings, but there's 3 settings here. And there's this base class. It's not called a base class, but this is this one config provider that has all the functionality we need, which is these three methods. Get message broker settings, that gives a message broker settings DTO. Get Cosmos DB settings, that gives you a Cosmos DB settings DTO, and get storage account settings, that gives you storage account settings. So imagine this to be the base class, and the base class has all of these methods all fully implemented, and maybe they're protected. And you could say, okay, then descendants can decide to make one or more of these methods public. They still have access to all three, but if one descendant just needs one of these methods, you have to make sure that it never exposes these two protected methods in the ancestor class in their own instance, right? But that's the basic functionality. We need these three settings. So in the program CS, we have this app settings. All right, so we have, this is a console application here. That's a library, which is the sort of part of the solution, if you will. It's not part of the original code. The original code is all here in domain layer. So this project is sort of the simulating the original code base. And then this library and this project, domain layer 2, is simulating the solution to the problem, if you will. Right? So if you look at the original, we have this config provider here we just looked at. Right? That's the config provider from the original. And it's all this all functioning. It works as expected. If you want to test it out, let's do that. So in my program CS, I've got that. And what I do is I get a instance of a manager. I don't need to know that, but the manager internal has got a method that says get message broker settings, which internally calls this config provider's get message broker settings that returns that. Okay. So if you would run it, you would see that the code should retrieve the config file settings from the config file and display it over here. So if you look at that, you'll have the message broker type is service bus, the endpoint connection string is so and so. All right. So basically these two, message broker type and the message broker connection string. All right. So now that's the original, as in the way the system is working currently, that's how it works. And our change or modification here is a library. So let's look at what are we trying to do here. So if you look at the three features or three functionalities, right? You got something that can get you message broker settings, something that can get you blob storage account settings, or something can get you Cosmos DB settings, right? So three capabilities. What if you could encapsulate these three capabilities into their own separate classes? And now your config provider is really comprised of the mix and match of these classes. These classes are self-contained and they have their whole implementation in there. Your config provider is nothing but a composition of one or more of these classes, and they get the functionality, right? It's a little more complicated to implement, but conceptually, that's what you're doing. So we want to have three different classes that have that functionality of retrieving the Cosmos DB settings, the blob storage settings or storage account settings, and the message broker settings. And if you can do that, and that functionality is reusable, then different config providers, and they don't have to be necessarily any kind of hierarchy, but each config provider can then say, okay, I want to be composited of these two features or functionalities. And some other config provider can decide, I want to be composited from these other two features, and so on. Right? So you can mix and match that. So if you look at the slide deck, we have this slide here. Let me just turn on my pointer. So we have a config provider base, and then we have descendants. So we use inheritance, but again, it's more single level down, or there's a flat or shallow hierarchy. It's not a deep hierarchy. And each descendant can in turn decide to be composited from one of these three classes. So these are the three classes. The message broker settings is one implementation that has some functionality. Cosmos DB settings has got its own implementation, fully featured functional implementation for retrieving Cosmos DB settings. And the blob storage account settings does that. And what you're seeing in the next level down here is each of these config providers that are descendants of the base class are able to be composed off of the functionality they require. So this one needs these two, this one needs these three, this one needs this one. And so you're free to make any permutation of these three as part of the config provider you require in your current project. And you're getting the benefit of reuse. You're using a simple form of inheritance, but essentially you're using composition to get the functionality, right? So the inheritance is probably because there is some commonality, and I'll show you the code there, that is truly reusable across all descendants. All descendants will need that. That's rolled up in the base class, right? Let's look at the source code here. If you look at so I'm going to this library project here, the composition or inheritance core library. And in here we have the config providers that has the settings provider. If I look at the config provider base, you will see that it has some functionality. Essentially, it has this functionality. All the loading up the JSON and the environment files, JSON files, and so on and so forth. It's all implemented here. All descendants get that feature functionality for free. And then on top of that, it has this one method here. This is initialize configuration section retriever. And essentially it's returning an I configuration, or the section, if you will, right? So we have the configuration section retriever, and the descendant classes don't use this directly, this configuration section retriever, but the classes that implement the settings. So here's the Cosmos DB settings provider. So this is that one class. If you look at the slides here, Cosmos DB settings provider. So the three features of functionality that we want to reuse by way of composition in our descendants here. It requires a config section retriever in its constructor. So it can use it to retrieve configuration or section information to then construct this and retrieve that or return that. Right, so each of these requires that in their constructor. So the config provider base class has the functionality there. All descendants have automatic or free use of that configuration section retriever and loading up of the JSON files and environment files, and everything else that you want to use for your config sets. Stuff is in the base class, all right? And so then these specialized classes that provide this functionality here, for example, the Cosmos DB settings provider, it's got like these two methods that are specific to retrieving Cosmos DB settings from the config file, but it's effectively reusing or reusing the config section retriever to retrieve the section in which the settings are, meaning the app settings, this section. So it's retrieving this section from that, right? So we have the message broker settings provider. It does the same thing. It gets this configuration section retriever in the constructor. And then basically, again, it's got these two methods. And lots of all the validations in here as well. So all that reuse we're getting, and literally this code has been taken from that original config provider. So everything that you're seeing here is the code that has been literally copy pasted and put into the separate classes that are the providers, the Cosmos DB settings provider and the message broker settings provider and so on. And so that refactoring was basically reusing some of the code here. The configuration section retriever is brand new, and we have that one class here with its implementation and any validations that we do over here that is part of our config provider itself. I don't mean config provider, I mean the configuration system has to do the validations of all data that comes into the system, and so that's all done for you. So the difference is we have, if you look here in the domain layer 2 class, library, the config provider here is descends from config provider base, but it composites the three. In this case, it requires all three features, so it composites the three implementations, if you will. It creates the instances of that itself. Okay, so it does that. So now internally, it's not got the implementation, it's using the implementation by the composited classes. Right? So it's getting this reuse not through inheritance, but by way of composition. Prefer composition over inheritance is essentially saying that because of the issues that I talked about, especially I forget what they call it, but the hierarchies that happen that go into different branches, and then you might find you want something from this branch that is from that branch, and it just gets quite hairy. Plus my issue with it, which is you are potentially inheriting much more than you need. And I don't like that. It gets confusing, it becomes difficult to maintain, and at times the dev could mistakenly abuse the functionality just because they have it, they can see it. And I'm not a big fan of that. I've done that myself. So when I say devs, I don't mean like, I don't trust myself either. I mean, you don't remember the thought process you were at when you were designing the system. And 2 years later, you may not remember all the gyrations you went through and why you arrived at what you arrived at. I trust myself from the past. I don't trust my future self to remember the past, or any dev for that matter, any dev that was not part of the discussion. Right? It becomes hard to know what the intent was when you can see it all there. And so programming, the intent is about show me your intent. So if you don't give me a feature in a class, I understand that that's your intent, that you don't want that feature available. But if I see it and you're not using it, I'm not sure what you're telling me. Are you saying that that's an option I can use and I can see it there in a library or in an ancestor class? Should I be using it here or not? I'm not sure what you're trying to tell me when I see that extra feature set available to me. And that's what I have beef with. All right, so if I look at the functionality of this config provider now, which is in my domain layer 2, pretty simple. Just create a new instance of a manager from the domain layer 2 namespace. That's all I'm doing here. And if I run this application, you'll see that it's got the settings from the same config file. So the config file is the same. It's got the message broker settings, the message broker type. Here, let me zoom in. So you can see the message broker type is source bus, and the message broker connection string has got some value, right? So both the data is the same. I've tested that out and made sure that's actually happening on. And so obviously there's only one config file in the entire solution here. And so whatever settings it's getting is from the same settings. So I hope this has been useful for you to not only understand the hesitation that you should have when you're using inheritance, but also prefer composition over inheritance and what that means and how to implement that, right? Composition, just so you know, there's composition and there's aggregation. I probably mentioned this earlier in the video. The difference between composition and aggregation is essentially that composition is an ownership thing, meaning class A that composites classes B, C, and D, for example, owns the lifetime, is responsible for the lifetime, right? Whereas aggregation is not lifetime managed, meaning if some class is using other classes through aggregation, it implies that the class that's using the other classes is not responsible for the lifetime of those classes. It's using them but doesn't own their lifetime, right? With composition, it implies it's completely encapsulated. You don't even have to know its composition, as you can look at this config provider here. Which one is it? This one, domain layer 2. If you look at the class from the outside, it's got these public methods, which is pretty much all it's got. It's got a constructor, and that's it. There's no understanding from the outside that it is compositing these three classes, because these three classes are created internally to this config provider. It's not injected in or something else. And if these classes needed to be disposed, then this class, the config provider, would have been responsible for disposing of these classes when the time is right, which effectively would mean it becomes disposable as well. So any composition versus aggregation, they're sort of the same. The net result of functionality might be the same, but the way that's implemented is quite a bit different. You could say prefer aggregation over inheritance too, because I'm not sure that the fact that one's composition or aggregation is the benefit. They both will give you the benefit, but I prefer composition because I don't like to inject things from the outside, and then now my outside is aware of what the inside needs. And to me, that's a lot worse than being kind of self-encapsulated. So I hope this video is useful, and I hope you've learned a few things. If you have, please give me a thumbs up. and I will see you next time.